This is MYP3 Unit 2. It's called Back to Basics. It includes a lot of revision of stuff from MYP2 and some new stuff. So we're starting with Chapter 1, which is surds, square roots, radicals. You often hear lots of different terminology for the same basic thing. So square root of 16, for example, which is 4, because 4 times 4 is 16. So the square root of a number is the number that you have to multiply by itself to get that number. So a couple of questions. What is the square root of 100? What is the square root of 4? And what is the square root of 400? And you're supposed to notice something linking those things. So the link was that the square root of 100 is 10, because 10 times 10 makes 100. The square root of 4 is 2, because 2 times 2 makes 4. And the square root of 400 is 20, because 20 times 20 makes 400. Now, 100 times 4 is 400, and 10 times 2 is 20. So in other words, the square root of 100 times the square root of 4 is the same as the square root of 100 times 4. So that gives you a general rule that the square root of x times the square root of y is the square root of x times y. If you've got two numbers square rooted and then you multiply those two things together, it's the same as multiplying them together first and then taking the square root of the whole thing. So using that rule, you can see how calculations involving different square root values can have simple answers. So for example, if you take the square root of 3, it's 1.73205, lots more decimals going on forever without repetition. Square root of 12 is 3.464116, lots of different decimals repeating, going on forever without a pattern to it. So both two irrational numbers, they're called. And when you multiply them together, square root of 3 times the square root of 12, you get the square root of 36, because the square root of 3 times the square root of 12 is the same as the square root of 3 times 12. 3 times 12 is 36, so it's the same as the square root of 36. And the square root of 36 is, of course, exactly 6. So even though the square root of 3 multiplied by the square root of 12 comes from two values that have irrational answers, multiply them together, you get a nice integer whole number value. And you can actually check that with the decimals themselves. So if you get your calculator and do the square root of 3, 1.73205, and multiply it by the square root of 12, 3.4641016, you'll find that you get 6. Or you might find that you get 5.999, because these numbers here have been rounded off, but you'll get a number that you'll see is as close to 6 as makes no odds. And precisely, the square root of 3 times the square root of 12 is the square root of 6. And there's a similar rule for dividing. So the square root of x divided by the square root of y is the same as the square root of x over y. So for example, if you've got the square root of 12 divided by the square root of 3, that's the same as the square root of 12 divided by 3. 12 divided by 3 being exactly 4. So the square root of 12 divided by the square root of 3 is the square root of 4, and the square root of 4 is exactly 2, because 2 times 2 makes 4. And again, you can check that with the decimal values. So the square root of 12 is 3.4641016. Lots more decimals going on forever without repetition or pattern. The square root of 3 is 1.73205, and then lots more digits. So they're both irrational numbers, which means that you can't express them exactly as a fraction. But when you divide them out, you get exactly 2. So from two irrational numbers with unpredictable decimals going on forever, you divide them out and you get a nice exact integer value of 2. So there's an exercise here. Calculate the square root of 32, which I'm calling x, and the square root of 8, which I'm calling y, and then calculate xy, so x times y. And I want you to do it two ways. So do it from the decimal values, so calculating the decimal value of root 32 on your calculator, and then the decimal value of root 8 on your calculator, and multiplying those two things together. And then calculate it in another way from the rules you've just seen. And you should find that those two answers agree with each other. And then in the same sort of way, I want you to calculate x over y, so x divided by y, root 32 divided by root 8. So pause the video and have a go at that before you have a look at the answers. So here are the answers, a little bit rough. I hope you paused the video. So from the decimal values, the root of 32 times the root of 8 is 5.6 something times 2.8 something. And when you do that, it should come to 16. Might be a little bit more or less because you rounded the values, but you should be able to see well enough to appreciate that it's 16. When you do it from the rules, root 32 times root 8 is the same as the root of 32 times 8. 32 times 8 is 256, and the square root of 256 is exactly 16, because 16 times 16 gives you 256. So either way, you get the answer 16. Now dividing them out, root 32 divided by root 8, if you work out their decimal values and divide them out, you should get 2, or you might get 1.999 or a bit over 2 because you rounded something off, but you'll get close enough to 2. When you do it from the rules, root 32 divided by root 8 is the same as root 32 divided by 8. Root 32 divided by 8 is the same as root 4, because 32 divided by 8 is 4. And the square root of 4 is 2, because 2 times 2 makes 4. So doing it from two different methods, you should get the same answer. So the exercise on that was page 195, exercise 10A.